Hi guys, this is Sam here, and today I'm just gonna have this media service server which we have written on the C code extensively within the data structures. So this C code is basically will be a media server that's multi-threaded media server that will be running onto that, and it is using the libraries with the threading and with the different libraries. So our purpose will be the media server is running. It's a multi-threaded, multiple clients can come and basically connect to this Genu TCP Lite server, and basically they can have the all the files which are media files or the chunky files can be basically streamed to them. So we'll find different devices that would basically work onto that. So we will use a basically model 3B plus, which is a good model of the Raspberry Pi. And the benefit is I already have the cobbler connected. If you look at, see, I have this model connected. I'm using HDMI because we'll be running the client right across on this in this Pi model 3B thing, and show how fast is that. It is able to communicate with our server. I have the server which is running on this port which is 101. So let me go out here and say, so if config, and you will sign that. So I have 101, my EN0 network, if you look at, is 101 thing. And I'm gonna basically, I have a one client which is running on this particular Mac OS Intel x86 chipset, and I'm also having a client which is running onto this thing, and both will connect to the light server. So we have the light server out here which will be basically creating a huge file and do that. So let's go out here, and first before we run, we just want to make sure, hey, let's remove the file. So it will create a huge file which will be played by any media player. This is more about the client to this communication. So let's go out here, RM. I'm gonna remove this MP3 for Genu file. Let's type it is better. So we clearly say right now this media file in the client side is having 0 file, and you find over the time when the media server client runs and the media server runs, it is going to basically get all this data out here. Let's go out here and look at this one. So this is our file. I will basically clear it. So we have and let's first run it, and then we can come to the explanation. So I have SVTCP log. This is the light server. So I'm running the SVTCP Lite at 51,000 port. This is the media server. So as you see, the media server is running 51,000 port. It has created all the, it's running and it's listening on to the multiple threads. So we're gonna come here and say, okay, we're gonna run this a client. So we want to tell him, hey, where you want to connect. So we want to connect to 10.0.0 at 101. Okay. So you see the exchange is happening, the thread server has running, the media service is being served. All the media files are using a protocol on the RDSP basically, and they are basically, the data has been sent, and we're gonna now look at it it clearly says, hey, the server did log down. Let's go to the server messages and see that I put a very light onto that. As you saw that it is up to the flushing, the f flush that is would be happening. So we have the whole amount of the data chunks that are basically listening and seek happening, and the files transferred out here. And it also send, hey, there is the file, and it says, hey, the server has sent a response message of the data, and this is end client ended successfully. So it says, hey, there is a stream file success has happened, and then the command has basically issued by the TCP, by this client, saying that, hey, by the Pi client, hey, log me out, right? So there's a user send logout Janu. So he says, hey, I logged in a Janu. The whole protocol exchange between the two guys happened to be very successful. I've received all the packets. I have the checksum done. They're all good. Now please log me out. So when the command is log out, it says, okay, I'm going to basically log it out, and calls a client with the logout, the data, and they happen. Now let's look at the file. So you see this, we had 68.505254. This file is the file that has been streamed by the server. Okay, so the file has entirety come into that, and let's go and look at our code also here. So we have a little to glimpse on the code. This is the client code. Let's walk on the cloud code. What is happening? So basically we have a client, right? So we have a client. We are using these libraries, defining the max buffer length, TCP, and there's an out file which says, hey, this is where I'm going to basically, out file is Janu. I'm using FCNTL field, and netinit, RPA init, and pthread, right? So we are not on the client side, and then we have defined a S3 connection, and then we have displays here, and there's a stream file. So basically it makes a connection here with the client library to stream the file, right? And then it makes a communication call over the protocol using AFI net asset with a socket address, and do that. So I have a file open, out file Jano with RDR write, so that it can read. Then it calls a read SD flight client with a buffer stream and buffer length. Now let's come on to the little server side. So this, we ran it. We could have run a connection with the connection with the Pi on this one also, but we want to show that, hey, we want to see that, hey, this is a client, and the client is able to successfully communicate with a TCP, basically a media server which is running right across the on this server. So I have 101 where this media server is running. So media server has like the mutex. Let's go to the server. It's pretty fast, right? So it has the code here. So we are using the pthread mutex to lock, because what happens is, first time when we call, there are these bucket commands. So for the buckets to end the media file, so the media files, the buckets are there. So it is going to send the media file commands land, and then sends a command to the sender and receiver with a command, right? And we lock our mutex file, right, while sending the command, right? And we are looking for this. So one thing that we have, we can do multiple commands. So I have the commands which are done, which are, wait a minute. So we have the commands for the media files. So there are multiple commands that you can do onto that. So these are the commands, different commands that it's a very big. So we can cover that whole in a different session. So basically there is a user, when it adds, it tries to goes and add a remove user, right? And so this, wait a minute. So we have the command here, and we have the media file. Then we are calling the mutex thread, and we have a socket with pfnet. So, and pfnet is for the UDP, and if we have, you can use the AFI net, right? For this one, and we have a server, and then we get the socket name. We need to resolve the socket name, because whatever the sock name is there, if the socket name is not there existing, then we listen to the connection. And once we listen to the connection, if the connection listening is error, then now we are doing a select call to poll. So we want to see if the FD set is there, right? So we want to see FD set. So by default, we using the macros FD0 to basically initialize all our FDs, right? It's very cumbersome otherwise. So we use FD0 macro, then we FD use set because we got a socket and we are adding to the socket and we are delegating to the select command to see, hey, is there any activity happening on our FD? And then we create a thread, spawn a thread, and do that. So this is what is happening onto that, and the server is streaming the file and checking it, and we are printing it out. So this now let me go out here. So what about if I have multiple clients? Okay, now we want to say that, hey, we have multiple clients and this is another client that I'm running onto that. Let's go, the server is still running onto that. You see this one, and we're gonna go out here and say, hey, wait a minute, clear, okay, 51,000 pod, all right. And now we're gonna run this another client. This client, this time we are running on this Mac. So we done with this, we know that, hey, this model 3 TCP client, which is compiled out here, it is able to communicate with the media server here. So we have, this is again, folks, this is a native written, all the code using the C library. It's not C++. Again, it's entire C code with all the data structures built in inside that, and it's making a protocol layer connection to the client. So we want to make sure, now we have this. Let's go out here and so I am compiling it, freshly compiling it. So we already have here a compiled version. To save the time, I'm gonna run this command onto this 10151,000 port. Okay, so let's run it out and see what happens. So it's clearly, this is much more elaborative. It says, hey, there's a protocol connection between happening that this client and this one, and I have an index coming out of this, the child sites, and then there is a login happen, right? And the media files are streamed out, and it's a logout happened onto that, right? So this end is connection. So the server is still listening, right? Now we can make another connection to this. Let's now make a connection again from the Raspberry Pi, okay? And we're gonna remove the file and the touch file so that we can see that, okay? This one, server is still running. We're gonna again make a connection, okay? And let's run this. So we have the server running 50,000, server is still listening. It's a multi-threaded connection, one thread, one particular connection, one client is on this one, which is already done. And we have another client, which is on a different device. It's a small device. You see this guy is a very small device. Everything is running onto that. We just don't want, we have connected HDMI so that to give a visual indication that, hey, wait here, this client is running on this one for streaming. And we're gonna run this guy. You see, it's running, and all the packets are, you see, streaming from the server and going to the client. They're onto, this is a very small device, and it's very very light fast. So it goes out here and it says, I got the data, and it's printing all that. There are 8467 file. So let us do that. So what we got from the server. So you see that we have got again same file. So last time if you remember, it was 68.5 MB. So again we got 68.5 MB file. So with this, any kind of the files, basically the server, basically the light server and this client is able to communicate across multiple devices. Thank you. Once again, this was Tham, and this is the library code that I have out here. I just walked about the code on the client and on the server side back. Have a great day, guys.